Look, nobody likes pain. It is the worst subscription service on the planet, and none of us clicked subscribe. Yet, here we are, stubbing our toes on coffee tables and wondering if life has any meaning. But have you ever stopped to think about what is actually happening upstairs when you feel that rush of agony? It is not just magic. It is a complex, high-speed data transfer that your body runs better than your Wi-Fi router ever could. Today, we are diving into the specific machinery of how your brain processes pain. We are going to talk about nerves that scream, highways of information, and the specific part of your brain that acts like a dramatic reality TV judge. So, sit back, relax, and let's figure out why things hurt, hopefully without actually hurting you in the process. What are nociceptors? Let's start with the specific noun here, because that is where the money is, both for advertisers and for your survival. You have these things called nociceptors. Say it with me, nociceptors. These are not just regular nerves that tell you when you are touching something soft like a kitten or a slice of pizza. No, these are the specialized nerve endings that are strictly designed to detect annoying, potentially damaging stimuli. Think of them as the overzealous security guards at a concert. They stand around waiting for something to go wrong. When you touch a hot stove, it is not the heat that hurts you instantly. It is these nociceptors firing off a flare gun to your spine. They are picking up on thermal, mechanical, or chemical changes. If you get a paper cut, mechanical nociceptors are screaming. If you eat something way too spicy, chemical nociceptors are losing their minds. It is a very specific job description, and honestly, they take their job way too seriously. They are the reason you know the difference between a high five and a slap in the face, which is a pretty important distinction to make at family reunions. How pain signals travel to the brain. So, the alarm has been tripped. Your nociceptor has had a meltdown. Now the message has to get from your burned finger to your brain. This is where the specific intent of the signal comes into play. This information travels along your peripheral nerves, which are basically the fiber optic cables of your body, until they hit the spinal cord. Once they hit the spinal cord, things move fast. We are talking about a specific relay race. The signal jumps from nerve to nerve, heading straight up the spinal cord like it is in a hurry to catch the last train home. This highway is crucial because if you sever the cable, no internet, or in this case, no pain. This is why people with spinal cord injuries might not feel pain in certain areas. It is a harsh reality, but it proves the system is wired for specific communication. The signal does not just float around your body like a ghost. It takes the express elevator to the CEO's office, the Somatosensory Cortex explained. All right, the message has arrived at headquarters. It hits the brain, specifically the Somatosensory Cortex. This is the specific real estate in your brain that maps out your entire body. It is literally a map. It is kind of funny, actually. The amount of brain power dedicated to each body part is proportional to how sensitive that part is. So your lips, your tongue, and your fingertips have massive amounts of brain territory dedicated to them. Your back, not so much. That is why a kiss on the lips feels very specific and detailed, while a pat on the back is just okay. Someone touched my back. When the pain signal hits this cortex, your brain finally realizes, oh, my left pinky toe is currently suffering. It identifies the location and the intensity. It is the brain's GPS system putting a pin in the map of your misery. Without this specific processing center, you would know you hurt, but you wouldn't know where, and you would just be a confused mess of anguish. Why pain feels emotional. Now, here is where the plot thickens. Pain is not just a dot on a map, it is a feeling. It makes you mad, sad, or just generally grumpy. That is because the pain signal does not stop at the somatosensory cortex. It has a layover in the limbic system. This is the emotional center of the brain. The signal hits the amygdala and the anterior cingulate cortex, which are fancy words for the place where feelings live. This is why heartbreak hurts physically, or why a stomachache ruins your whole mood. Your brain is processing the physical sensation and the emotional reaction simultaneously. It creates a memory of the pain so you do not do the stupid thing again. It is the brain's way of teaching you a lesson, kind of like a parent, but with more neuroscience. The brain is connecting the physical input with an emotional output, ensuring that you remember that touching a hot iron is a bad life choice. How the body blocks pain. Here is the cool part. Your body is not just a torture chamber, it comes with its own pharmacy. When you are in serious trouble, Like running from a bear or trying to finish a marathon, your body releases endorphins. These are natural opioids. They bind to the specific receptors in your brain that process pain and essentially turn down the volume. It is like the brain has its own do not disturb mode. This is why soldiers in battle sometimes do not realize they have been shot until things calm down. The body realizes that dealing with the pain right now might stop you from surviving, so it hits the mute button. It is a survival mechanism. It is also why rubbing your knee when you bump it actually helps. The sensation of touch competes with the sensation of pain for the brain's attention, and sometimes the brain gets distracted by the rubbing. It is a low-tech solution to a high-tech biological problem. Phantom limb pain science. Let's get a little weird for a second. There is a phenomenon called phantom limb pain. This is when someone loses a limb, an arm or a leg, but they can still feel pain in that missing limb. It sounds like a ghost story, but it is pure neuroscience. The nerves that used to send signals from the arm are gone, but the brain's map and the somatosensory cortex still has that arm on file. When the nerves near the stump get triggered, the brain misinterprets the signal as coming from the missing hand. The brain is stubborn. It does not like updating its map. It insists the limb is still there, and it insists that it hurts. It is a glitch in the matrix, a specific error in processing that shows just how much of pain is actually generated by the brain itself, rather than just the body part. It proves that pain is a construct of the mind trying to make sense of input. Why we feel pain evolution. So why do we have this system? Why didn't we evolve to just not feel pain? Because if we didn't feel pain, we would be dead. It is that simple. There is a rare condition called congenital insensitivity to pain. People with this condition do not feel pain. It sounds like a superpower, right? But it is actually a nightmare. They end up with broken bones they didn't know about, burns, and infections because they lack the warning system. Pain is the ultimate alarm system. It is the check engine light for your biological vehicle. It forces you to stop, protect the injured area, and let it heal. It is annoying, it hurts, and it makes you want to scream. But it is the only reason you haven't chewed off your own tongue or walked on a broken leg until it fell off. Evolution designed this system to keep you alive, not to keep you comfortable. It prioritizes survival over your happiness, which is kind of rude when you think about it, but hey, it works. So, the next time you stub your toe, take a moment to appreciate the high-speed, high-precision biological machinery that is freaking out inside you. From the nociceptors screaming at your spine, to the somatosensory cortex mapping the disaster, to the emotional center ruining your day, it is a team effort. Pain is specific, it is complex, and it is absolutely necessary for staying alive. If you enjoyed learning about the inner workings of your brain's alarm system without having to actually get hurt, make sure to hit that subscribe button. It helps the channel more than you know, and it is completely painless. Stay safe, watch your step, and remember, your brain is just looking out for you, even if it feels like it is trying to kill you.